All right, thanks. So yeah, I'm Marc West. I'm with NVIDIA, account manager. I work with 6 research universities here in the Midwest. I use one of those. I've been with NVIDIA for 3.5 years. Before that, I was with IBM for 16 years. So I've been working with research computing technologies here at IU for a couple decades. So I'm familiar with you folks. I do remember when Matt Link's hair wasn't all gray. So, but yeah, NVIDIA is really quite different from most hardware companies. And like I said, I worked at IBM for a number of years. I worked at some microsystems, and their focus is the hardware in terms of what we're talking to customers about. And NVIDIA, we know how valuable the software ecosystem is around computing and GPU computing, because of, we were the pioneers. We had to go and create a whole software ecosystem around GPU computing. So folks like Kaleb, he doesn't come here and talk about our hardware. He comes and talks about all the software that we've built or the community has built around GPUs and how to utilize that. So there's a whole team of, most of them are PhDs, and Kaleb's team that we call solution architects. And those folks are here for free of charge to engage with you, the researchers, grad students, to help. So a lot of times we're behind the scenes working with Avanav's team and the research technologies team to help, but don't hesitate to reach out through research technologies or directly to us. We have guys who will roll up their sleeves and help you with your code to get it running on GPUs or to get it optimized on GPUs, or guys like Kaleb to work on what AI models, most appropriate for your problem that you're trying to solve. So those are the types of resources that are available to you from NVIDIA. You guys, Indiana University has made a huge investment in GPUs here with Big Red 200 and then JetStream 2, the NSF system. And we have technical resources to help you put those hardware resources, those computing resources to good use. So yeah, take advantage of us. I've got some business cards. You can stop and flag me down and get a business card. But at that, I'm going to turn it over to Kaleb.
Awesome. All right, everyone. Thank you for being here. My name is Kaleb. I'm a senior solutions architect, but my role is actually senior data scientist as well. So I'm more focused on the AI and machine learning for higher ed research. And I also am the site lead for something we call the NVIDIA AI Tech Center. So the NVIDIA AI Tech Center is based out of the University of Florida right now. As you all know, University of Florida had a huge donation from NVIDIA and the state and things like that, where they got a gigantic supercomputer, 140 node DGX A100. So roughly, what is that? Over 1,100 A100 GPUs, 80 gigs. It's a monster machine. So with that, we established the first North America NVIDIA AI Tech Center there. And I am the site lead there. So basically I work with researchers to not only evangelize the NVIDIA platform, but I work hand in hand with researchers that kind of promote our technology in their research to make a big boom for UF, right? And we've seen huge success with that. So we came in, UF was about 16th on the top 100 list for research, and we've moved them up to, I think, top 6 or top 7 right now in a year. Great success, great power, and it's all with the NVIDIA platform, right? That's what we'll say. All right, so a little bit about me, because you don't want to sit here and listen to me talk for 2 hours and not know who I am. So these are my kids, they're my life. If I could get paid right now what I do, I would rather just hang out with them, obviously, right? But I do love AI and machine learning. It's a big hobby. So my PhD is in machine learning from a small school called Florida Tech. It's in Melbourne, Florida. And my background for my dissertation was on deep generative models for time series analysis. So generating time series data with deep learning. These slides will be available. So there's my Google Scholar too, and my LinkedIn. So feel free to add me, and anytime you can reach out. Like, I don't mind talking or chatting about research at all. And then, you know, before I grew my beard out, I felt like I looked kind of young. So I always want to let you all know that, like, you know, I'm not here just because I got a PhD really quick and came out. So before NVIDIA, I got my master's in computer vision doing custom CUDA kernels for video tracking. So actually going in and coding in CUDA and using the GPU. And I used the K2000 when I got my master's, 4 gigs of RAM. Just amazing what we've gone to, right? And then I got hired by MITRE. It's an FFRDC, federally funded research development company, the largest one in the country. And I was a subject matter expert for machine learning and deep learning for them in their emerging systems technology group. Sounds really cool. It was very boring. They just wanted to really amplify how they put things in Excel databases and stuff. And I was like, this is awful. Luckily, I got headhunted. I did a couple cool things at MITRE though. But I got headhunted by a DoD contractor where they wanted me to lead their AI prototype lab for the IC and DoD. So that was a great stint, right? 6 to 9 month contracts we were trying to get in and out. And I built a team from just myself, getting overhead charged about 5 million in 2 years and about 12 people under me. Loved that work. And then when I came to NVIDIA, it's really similar to that work because I have no subject matter expertise in one domain, right? So it's not like I only do NLP or I only do time series analysis. I only do vision. I literally do everything. And that's because I support all the researchers at UF. All right, so we had a great talk about, you know, getting started and repositories and stuff like that from Scott. So right now we're going to talk about a little bit about NVIDIA NGC containers. We have a ton of containers on our platform, right? It's amazing what's there. And, you know, when you're using a cluster, it's kind of interesting to think about using a container, right? Because we all, on our local machines, at least I was guilty of this for a long time, I would just make a Conda environment, right? You run your stuff and you got your Conda environment. But then when you push that to GitHub, I don't know how many of you have used a requirements.txt on a GitHub that never, ever builds correctly, right? It's awful. So that's kind of where containers come in, right? Where if I have a container and it works for me on my system and I just shove it over to you, hypothetically, it should work exactly. And the NGC is where this is housed too. So that's the NVIDIA GPU cloud. And don't worry, I'm gonna switch screens. We're gonna get into all this stuff too. But it's full of everything, right? So let's see, new share. Just bear with me, y'all. Cool. All right, so that's not the cloud. Here we go. This is the NVIDIA NGC. And it's really remarkable because it's full of everything, right? So you can start by like querying what you're interested in. So if you're interested in computer vision, oh, I typed that in the wrong thing, didn't I? There we go. Boom, everything comes up that we have under computer vision. And I mean a ton of stuff, right? And again, this isn't me talking like our SDKs or anything like, right? This is open source things you can pull today and use on Big Red, your other systems, even your local machine. And in here, it's not only containers, but we have pre-trained models, which is huge, right? And you can guarantee any pre-trained model you get from the NGC will run more efficient on NVIDIA GPUs than what any other model you get from a GitHub or open source, right? It's guaranteed because we have engineers dedicated to making sure everything runs at peak performance from the NGC. And I'll get into a little bit of a storytelling here soon about like actual use cases, so you don't think this is all just fluff. But let's say you're in the object detection, right? That's a hot topic. I do a bunch of object detection stuff and did a bunch of object detection stuff with the DoD. But it's also full of information, right? So it tells you a little bit about what object detection is. It goes into an introduction. How does it work? So it's like a glorified senior design report that's so high level and in enough detail that if you're new to it, you can pick it up. And if you're experienced, you can be like, that's exactly what I need. Autonomous driving, warehouse surveillance, all that stuff, right? So stop that share. Go back to the PowerPoint. Let's see if this works. It did. All right, this is great. So we're going to get into a little demo where I actually get on Big Red 200 I'm going to pull a container, and then I'm going to run some code. And then we're going to get into a hardcore demo where I show a way to get Jupyter Lab on Big Red 200 through the container, which is important, right? Because that's all your Python, Jupyter notebook scripts. So it's really cool. And we'll talk through all this, right? But I mentioned some stats. So we're going to pull the PyTorch container from our NGC. And we were working with researchers before that had code that was training in 25 hours with PyTorch. It was medical imaging. They were training a segmentation algorithm, 24 hours to train to some convergence that they deemed fit. So we went in and we said, hey, look, let's look at your environment. They told us what they're doing. And we said, all we want you to do to start is just pull our NGC container and run it. Don't change any code at all. And we went from 25 hours, I think it's 25 or 24, to under 15 hours, just running it on the container. And you're like, how is that possible, right? Again, we have experts that spend hours optimizing these containers so they run at peak performance on NVIDIA GPUs. So that should make you excited there too. You know, Matt mentioned at the beginning of all this, time is like our most valuable asset. That's exactly what NVIDIA's push for all you researchers are when it comes to our SDK and softwares, is if I can get you to do more research faster, then you can get more papers out, you can win more grants, and most importantly, we can change a lot of problems that are going on that we hopefully can solve, right? Big impact to the community. All right, so with that said, I should be able to just pull a command. Yeah. All right, so I am going to log in to Big Red. Everyone can see that? That's big enough, right? Yeah. Now, a lot of the stuff I'm going to do in the demos, I've already done because like building a container takes a little bit of time. It took like an hour. So it's already there, right? So we don't have to worry about that. But right now, all I'm doing is just logging in. And even this takes a hot second. But yeah, in the container like repo, I mentioned we have the containers, we have pre-trained models, and we also have like tutorials and scripts and stuff like that. It's basically everything you would find on your local computer if you download a GitHub repository, weights, environment, et cetera, just packaged in one deal, right? And it's the optimal way to run on clusters for sure. Okay, so we're in. So I have pulled the NVIDIA NGC container and put it under Slate, but all you would do, and I have it here in the slide, right? We're gonna look at this next slide. Is this right? So let's start from the beginning. This is a flow. So we want the PyTorch NGC container. So we go to NGC, we type in PyTorch, and we just grab that container, right? And we have time, we'll do that. There it is. Oh, man, my scrolling's crazy. There it is. So we'll click on that. And again, remember all these containers, all these things you click on, they have a bunch of information about what's going on. So this is a PyTorch. It's the newest pool PyTorch they have. And right here, it tells you how to do it with Docker, right? And Docker's great. We love Docker, but you know, Big Red and a bunch of big clusters run on Singularity. So it's an easy thing to do. So what you'll do is just copy this path for whatever PyTorch version you want. And if you look at my slides, in the very right, nope, middle, right here. Oh, it doesn't say, I can't zoom in. Oh, here we go. Boom, right here. Singularity pool, Docker, // your URL. And that's all you got to do. That's the only difference. Now, in the previous slide, I struck through the Docker pool. It's Docker pool. And Singularity is just 2 words different, right? So it's super simple. Don't get scared. It's a breeze. And it just starts building for you, right? It copies it over and you're good to go. So back to this. So I have that, and it would look like this. And that's all we would do. I'm not going to do it because of, time, obviously, but I have this already done in my slate. So I also downloaded the PyTorch examples from their GitHub, right? I'm sure it's in the PyTorch container. We don't want to mess with that right now. I just wanted to show a quick example. So if we CD into that, we basically just have a bunch of PyTorch examples we can run, right? There's MNIST, of course, which we will do. ImageNet, Legacy, that's a bunch of older things. There's docs, of course. DCGAN, which I'm a big generative guy, so having any examples with generative models is awesome. And Siamese networks, they're really popular, That's one of those few shot learning attempts. VAE is also very popular. But anyways, so we're in examples, right? So there's two ways to do this. And you can do an srun. Well, let's just do it the wrong way first. How about that? So to run the Singularity container, you can run Singularity shell. Oh, I got to point to it, sorry. And oh, here we go. Nope, slate. Thank you. And there's my container. Oh, I got an ML Singularity. All right, back up. Got a module load, Singularity. Okay, so you can do it module load or you can hit ML. Either one works. ML is just quick key, I guess you could say. All right. And what you'll see now is I don't know if that's, no, it won't. My login and everything on the head node is now just Singularity, right? And what's neat about that is it takes you back to your home. So if we go into this example and I go to MNIST, you can see there's a main.py. This is straight from the GitHub. I haven't changed anything. We'll just run Python main.py and it will start running. So we didn't do any environment downloads or anything like that. We just ran right inside the container. Now, we will wait until it starts running. There we go. Look how slow it is, right? It's painful. Well, if you remember when we started this, we did not allocate any GPU whatsoever. So this is not the right way to do it, the way I just showed you. But it works if your code is not going to run on a GPU. So remember when you do this, you have to allocate your resources before you run a Singularity shell. And I'm going to cheat because I never remember between the systems I'm on. And I did not use the reservation yet. That's okay. It should, yeah, they were on. So then you just do the same thing, right? So I literally can just scroll up. Oh, come on, you. I just don't feel like typing everything back in. There we go. So nothing changed except I allocated my GPU. And now we're going to run the same shell script, same Singularity shell, my container. Give it a second. Cool. Again, it puts you right back at home. So I can do Python, examples, MNIST, main. All right. And remember how it kind of inched along. I wish it would have the timing up there. I don't know why it doesn't. It kind of inched along at the beginning. Well, this is, I guess, the lag in the computer, the bandwidth, but mine's flying. All right, cool. So Singularity shell, make sure you allocate your resources first, then do Singularity shell. So that's the easy one, right? That's the easy demo. Now we're going to do the fun one. So I put this as Monai going hard. So my colleague, Dr. Ju, out of, she got her PhD up in Boston. She's a neuroscientist. She works in higher ed research with me. She works and helps me with the University of Florida a good bit. And she's done tutorials on how to run Monai on Hypergator, that big superpod they got. So, you know, that's all fine and dandy, but many of you probably don't know what Monai is. So Monai is our computer, it's our medical imaging open source toolkit. That in the slides when we get to them. but it's full of tons of valuable information on how to do basically any kind of medical imaging you can think of, 2D, 3D, segmentation, classification, and so forth. And they have the state-of-the-art pre-trained models already in there too, right? And you can pull MONAI container, and that's what we'll attempt to do, but I won't do it real time. And this stuff on MONAI is actually what wins these conference competitions at like Mackay or CVPR, things like that. So these are top NVIDIA researched algorithms, like NVIDIA research, their algorithms for medical imaging gets put right in the MONAI. And the greatest part about MONAI is if you pick it up and you want to use it for your medical imaging research, and you actually get something either we don't have in MONAI that your research is just beautiful for, or you beat one of our state-of-the-arts, you can push it back into open source, and the MONAI team developers will just love you for it. And it can be an open source community where you give back to the community, right? All right, so let's get into that. So before we do that, again, you'll have all of this because I'll have the slides for you, but it's Dr. Drew's GitHub for MONAI UF tutorials. And it's a step-by-step tutorial on how to use MONAI Core. So there's MONAI Core, and we'll talk about this again, MONAI Core, MONAI Label, MONAI Deploy, different tools that help you with your whole pipeline and flow. We're only gonna run on a single GPU. So the major steps here is we'll download the MONAI Core tutorial repository, we'll build a container, and then we'll run the scripts that are already in the MONAI tutorial scripts. All right, so you would log in to Big Red just the same. And if you use this, so I literally used it one-to-one and changed directories to Big Red from UF, right? So that's, all of this will work if you pull it up and run it. And that's all I did, that's all I did. So you'll sign in, and then you'll clone the MONAI tutorial. Again, I already did all this, so it's one of those things I don't wanna change up. But I wanna show you how to run a container in a SBatch file. So we will do that. So in Vim, I'm not a big fan of Vim, but this is how you're gonna go in and build out your container. So this is different than pooling, right? This is building the developer container that gets updated weekly. You could change all this, not pool that container, and just use, well, not build the container, but just use the container from the NGC, and you'll be fine, right? This just has all the up-to-date things in it. Every month you can rebuild it and get the freshest container instead of waiting for NVIDIA to update their NGC. Oh geez, Q? Yeah, it's always hard to remember that one. All right, so you build the container, you just do an SBatch. That shell script's right there that I just showed you, and it will actually go through and build a container for you. Dr. Drew told me it took about 6 hours on Hypergator to build. I think it only took me 2 hours for Big Red. But we will not sit through that. So I already have that built, and it sits right there. You can see MONAI Core, and that's where our container lives, our developer container. All right, so now we're gonna go in. We've already allocated that GPU that we wanted, right? I'm already on that node with the S run. So now we're going and we will look at doing the same shell command to run a MONAI script. Now, I did nothing different except have 2 different containers pointing to where my script is, and you can see how easy it is to just change in between environments, right? That's what I'm gonna do. So what is that's what I point to. Did I spell it wrong? Look at you. All right. And this one's weird. It will pop out a warning, sometimes an error, this U name, but that's okay. Because as long as singularity comes up, we're in the container. Boom. And then it's the same exact thing we did last time. We're just gonna run a Python script from the container, inside the container, in the tutorials of Monai. And then it's 2D. And then it is, there we go. All right. So we're just gonna train this now. I didn't prepare for the lag and how long it was going to take to run it. I'm trying to think of funny jokes I can tell. So I'm from Florida and it's very cold up here right now. Not a joke. I'm very cold. But I hear that, you know, it's going to get warmer as soon as I leave. So you're welcome. But you all have a beautiful campus. I drove past on University. I'd never seen that much foliage before. It was gorgeous. So I live on the east coast of Florida, and we got tons of storm surge. So I live on a canal, and it went up about 3 or 4 feet. I luckily have a new seawall, so it didn't affect me, but my neighbors who have their 1970 seawall, it was going up into their patio, into their pool. And once your pool floods in your patio, you're doomed, right? So I was running around with sandbags for the entire time, but nothing compared to what happened to the West Coast. All right, so we're getting ready to go. It pulled everything we needed. There's our dependencies. This is all in PyTorch as well, right? And we're doing a 2D segmentation off of UNetter, which is a winning segmentation algorithm in medical imaging. And this runs through, it gives you your epochs, it'll change it, train it, and it's pretty fast. I don't know if we want to go through 10 epochs, and it starts giving you your dice score as well. That's a big segmentation metric, is the dice score, especially with medical images. And what's nice about this is, you know, with a lot of Monai things, once this is done, it automatically saves your best checkpoint. And then you can use that for any downstream tasks you have that you've already trained your model for on your own, right? And there's a ton of downstream tasks already built in Monai GitHub repository. So there's a bunch of great things you can do with it. And then this isn't by no means to be like your research project, right? Say you're using UNetter on a new data set, then that's a novelty, right? That's something that hasn't been done. But if you're using UNetter on a data set that's already been done, I think this is like liver or spleen or something. And you're like, wow, so this is actually gonna get a pretty good dice score. But you're like, man, I think I can do better than that. The beautiful thing about Monai is it's all PyTorch based. So it's nothing special other than a framework collection, right? Of PyTorch code. And you can go in and customize loss functions in Monai, just like you would PyTorch. You can customize architecture, just like you would in PyTorch. So if you have UNetter and you're like, you know, I think I'm gonna add a new head to UNetter that has a special loss function, you can do that. You know, it's not impossible, it's super simple. It's as simple as using it for PyTorch. Okay, so we got that, and let's see. We'll exit out of the container. And you can see there the best metric model segmentation 2D DIC path. That's a PyTorch script, PyTorch weights. So we have everything, it even gives you your runs, because they are not things I had beforehand. All right, so before we get into the next one, which honestly, I don't know if anybody knew you could do Jupyter Lab tunneling through a container. I thought it was pretty cool because 80% of the PIs I work with at University of Florida and other universities use Jupyter notebooks, right? And not having OOD or Jupyter Lab installed on a cluster, it's detrimental to them, and they'll just go to Google Colab or AWS or something that has it, right? But all of NVIDIA containers like Monai, Rapids, PyTorch, et cetera, and we'll talk about those, they have a Jupyter Lab already built in that you can tunnel through. And it's remarkably simple with the script that Dr. Ju made. So yep, it just trained on 2D segmentation based off a dictionary, not an array. And we got a pretty high dice score of 0.99. And I think that's what they submitted to a competition and ended up winning. So that's a beautiful thing too. You don't have Josh and Jill's code that they did for a senior design project in their parents' basement that they load a checkpoint and they write a GitHub that says, oh yeah, we won this competition. Look at our leaderboard. Like this is tried and true and validated, right? And then accelerated for the containers. So speed of time to research, right? That's what we're after. So if we go into the MONI UF, wait, did anybody have any questions before we do this? And this is the only demo I have. After this, you get to listen to me talk about stuff. So during the talk, you guys can ask questions too. It doesn't have to be towards the end because they allocated so much time for me, which I'm thrilled about. If we go in that MONI core single GPU and we hit Vim launch Jupyter, now we can see what you do in an S batch to actually run a container. So you can see we had the module load in your S batch. And if people aren't familiar, S batch is how you do an allocation from Slurm to run, and you just wait your time. Instead of doing S run, you just do S batch. And I'm on the GPU partition. I have 2 CPUs per task. I allocated 1 GPU node. And I did do 14 hours because I tried this morning and I couldn't get the timing. Like it wouldn't allocate any resource. So I panicked and I was like, well, if I catch it, I'll just have it for the rest of the day. And we have it. And then this is the command in SBatch. So you do singularity exec, you point to the container, and then we have a script called Jupyter Lab in this GitHub. So if you were doing Python, and you had a main.py, be singularity exec, point to your container, and you can see this --NV. That means it's an NVIDIA container, right? So that gives some more acceleration to the actual push of the container. But it would be singularity exec --NV, our NGC container, and then Python main.py, right? And then boom, it will run it. All right. I'm in Vim. Q. Yes. Always happy when I figure out the Vim stuff. All right, so let's get down to it. We'll scroll this up a little bit. Random batch. So I already ran all of this, but I'm going to go through as if I'm launching this, and then we're going to see what there is, right? So it's very simple. Let's you do sbatch launch your Jupyter.sh, your shell script. Somebody say something? Ah, thank you. All right, so you launch your Jupyter lab, and you hit run, it will queue it, and then it gives you this beautiful out file. You can see that kind of above there, right? In my terminal. So if we cat that, I think the last one's 112, 52, 98, 9. Yeah. We get this long list of stuff. Oh no. Oh no. There we go. Just wanted to make this bigger. All right. So you run the sbatch, it's going to start training. It gives you an out file. All we did was look at the out file on terminal with that cat. And what we're interested in is 2 things. This is the node that we've allocated on, right? So this is the node on Big Red we've allocated on. And it gives you 2 ways of accessing this Jupyter lab. And we're going to actually look at the token here. That's important. And the script in the GitHub script. You just open a new terminal from your home. Did I already do that? So let me confess to this. I'm a hardcore Linux user. I love a black terminal. I will not use PowerShell because it's blue. So if you go into command prompt and hit PowerShell in Windows, it keeps the black terminal and you get PowerShell. Guilty, I don't even care if it takes a couple extra seconds to load anything. I'm not looking at blue. But that's where we're at, right? So hopefully this works since I already did it. We're going to SSH into this tunneling we did to port 8888 on our local host. We know what node we have the allocated resources on, and then your login username on Big Red. And then we wait. This, we wait a little bit. But I found this out, I was just fascinated, right? Because OOD is great, open on demand. It's great for clusters. Do you have open on demand on Big Red? Right, so it's amazing, but there's a ton of like IT support needed, right? You can't just customize it. So it asks for my password. Okay, do you have Jupyter Lab on it?
Yes, yeah. So I was saying that before Open on Demand was a thing, we had this something called Research Desktop, which is a thin link based VNC based desktop that we put in front of our Carbonate cluster. People log into it via either the browser or a client, and that gives them a desktop. And it does have Jupyter on it, and actually, because it is kind of attached to Carbonate, you just run your Jupyter notebook on the compute node, and then you get the host name, and then just put it into the Firefox browser on the desktop. So something like Open on Demand, but
Gotcha. All right, so this was a fake out, right? So when you do it right, it won't ask you anymore after this. So I already did it. If you get your password wrong, it tells you to enter your password again. But if it tells you nothing, that means you're good to go. So then we back out and we go to localhost. This just fascinates me. I just blown away that I could do this. And what's great about it, right, is if we back up, like your repositories here, oh, it's a little bit of a lag. But you can get all the way back out to like the entire Monai thing, like all the way back out to tutorials, examples. But then you just run things as you would a Jupyter notebook. So if you get to your right directory, everything's here, and you're running Jupyter Lab, your Jupyter notebook on an A100 on Big Red 200. And all we did was put the container on Big Red 200 and tunneled in, right? Nothing special needed. And of course, your kernel that's running is going to be whatever your container is, right? All of that environment. So pretty cool. All right, so that was it for the demo. Any questions? And yes.
So you were using a GitHub.
Yep. So exactly. So the question was, so you don't have to hand on the mic. The tutorial from Dr. Ju is based off of the University of Florida's computer. You see it's Monai UF tutorials. Well, Dr. Ju helps me with that, and she built out this how-to basically to do a ton of things with Monai on Hypergator. That's what we call the big superpod, Hypergator AI. But as I had mentioned, the only thing I changed was my paths. So I changed from my UF path, where I stay, to Big Red, and everything worked. I was very shocked by that too. But it was beautiful because you're talking a pure NVIDIA product like the SuperPod versus having just NVIDIA GPUs in a supercomputer, and it was one-to-one. But I will brag on this a little bit since we are going to talk about Monai. This is a public repo, so you can actually just Google UF Monai UF tutorials HW-Ju, and you can find this. But she has tons of stuff in here on how to get the Monai toolkit to work on a cluster. Monai multi-GPU is huge. We have a bunch of PIs that are trying to do multi-GPU because medical images are big, right? You get into 3D and 4D stuff and then, like the voxels are huge, the size is gigantic. The multi-GPU is needed. So super good resource. I have that in the notes of the PowerPoint. Let's see, scroll up right here. So when you get the PowerPoint, just make sure to look at the notes, but you can see the picture. All right, so that's it on the demos. We're gonna get into some relevant SDKs that we kind of brainstormed with your team, and we came up with a couple key points of research that everybody might be interested in. So I'm gonna talk about NLP. I'm gonna talk about Rapids, which Scott actually pointed to a little bit, but we'll go at a more high level and give you an overall sight of the package. And then we'll talk a little bit about vision. So what's interesting about vision is we have no computer vision SDK that just does computer vision, right? We have pre-trained models, we have PyTorch, TensorFlow, stuff like that, but that really is the toolkit for those. But I'll mention a little bit about MONAI, and then some interest in like the 3D rendering NERF things. I have no slides for that, but there's only a couple things out right now on our instant NERF, which you can do 3D rendering from images on like your cell phone, embedded systems, things like that. So we actually have a group from my alma mater using instant NERF to try to isolate satellite components in space with embedded systems and try to find real time with computer vision where things are breaking up there, right? So it's really interesting what you can do with that. All right, so NLP, any questions before we go on? Yes. Oh, so the question was, what's the difference between doing medical image segmentation with MONAI versus doing medical image segmentation with like PyTorch or TensorFlow? Yeah, so when you use MONAI, you're guaranteed it's community trusted. So I have some slides on MONAI. We have a huge advisory board. Before something gets pushed public, it goes through the advisory board of the top tier medical imaging AI researchers in the country. It's an open source platform as well, so everything's open, so it's easy to share as well. Medical imaging papers, I think we're up to like 40% of medical imaging papers use MONAI in the past year with conferences too. So it's tried and true is basically the key point. But of course, we're NVIDIA, we're all about time saved for research, right? It's optimized. You'll make sure you'll get the fastest way forward, right? Pre-trained models already in there, easy to go in and change config files, change networks, add custom losses. It's really nice in that aspect too. But then we also have some things, again, I'll talk about with MONAI when we get to the slides, but like MONAI deploy. So for imaging companies that wanna sell things to hospitals, et cetera, we have a way to track that and expedite how you deploy your model that you just trained for 2D segmentation for real world adaptation, right? And then we have MONAI label, which is the fastest, most intelligent way you can label all your data in the imaging thing, in your image data set. So we'll talk about that when I get there, but that's the key difference. NVIDIA backed versus just somebody in somebody's basement doing code, which is still cool. I mean, a bunch of Kaglers do that there and they're really good Kaglers, but that's it. Yeah, so MONAI has a ton of different things in there. The question was, can you do image classification as well? You can indeed. And again, when we get to those slides, I'll go ahead and show those and talk a little bit more of what we can do. Okay? Yeah. All right, we ready? We made it, y'all. That's me. You can contact me. But that's the end of the presentation and the demo.